How many critical points does this function have? F of x is equal to x plus 2 to the fifth times x squared minus 1 to the fourth. Pause the video for a second and think about how you would answer this question. Okay, do you have an idea? I hope you were thinking that in order to count critical points, we have to find out where the derivative is either equal to 0 or does not exist. In this case, f of x is a polynomial, so the derivative exists everywhere. So we just have to look for zeros of the derivative. We need to find f prime of x. Sometimes it pays to simplify before you differentiate, but in this case, if you think about simplifying, you would have to multiply out an x plus 2 to the fifth and an x squared minus 1 to the fourth, which will become quite complicated. So it pays in this case to use the product rule. So here we go. F prime of x is equal to, differentiate the first term, the first factor, 5 times x plus 2 to the fourth. Leave the second factor the same, x squared minus 1 to the fourth, plus, leave the first one the same, x plus 2 to the fifth, and differentiate the second one, 4 times x squared minus 1 cubed, chain rule times a 2x. This looks like a rather complicated expression to set equal to 0, but we're going to clean it up a little bit first, and hopefully that will make everything easier. So first, let's just multiply these terms together. 5 times x plus 2 to the fourth times x squared minus 1 to the fourth plus 8x times x plus 2 to the fifth times x squared minus 1 cubed. Notice that both terms have an x plus 2. In one case it's to the fourth, in one case it's to the fifth, and x squared minus 1 cubed and x squared minus 1 to the fourth. So let's factor those guys out. F prime of x is equal to x plus 2. We can factor out 4 of those. X squared minus 1, we can factor out 3 of those. And what's left is 5 times x squared minus 1 plus 8x times x plus 2. Let's just make a little more room so we can continue. We get f prime of x is equal to x plus 2 to the fourth, x squared minus 1 cubed, and inside those parentheses, 5x squared minus 5 plus 8x squared plus 16x. Clean this up. It becomes 13x squared plus 16x minus 5. And now we want to set that equal to 0. And it's already in factored form, so from the x plus 2 to the fourth, we see that x is equal to negative 2. From the x squared minus 1, we get x is equal to 1, or x is equal to negative 1. And from the quadratic factor, 13x squared plus 16x minus 5, if you want to try and do this without a calculator, since all we asked was how many critical points there are, we can do this without a calculator by saying, how many solutions does this quadratic have? And how do you decide how many solutions a quadratic has? Just look at the discriminant. Look at the b squared minus 4ac. The b squared minus 4ac here is 16 squared, which is 256, minus 4 times 13 times negative 5. No need to really multiply this all out. All that we need to do is notice that this is a positive number. What does it mean if the discriminant is positive? The discriminant is that thing inside the radical sign when you're using the quadratic formula. And if that's positive, it means that you have two solutions. So whatever those two solutions to the quadratic are, we have two more solutions. So we have x is 2, it's 1, it's negative 1, or there are two more solutions. That's 1, 2, 3, 4, 5, and that's the answer to our question. There are 5 critical points. The end.